Hello students, it is lecture 2. In lecture 1, I have explained about the syllabus. Today, lecture 2, we will start our study course, the chapter 1 of NCERT, Electrostatics. Electrostatics. I am B.S. Pandey, students. Now, we will start the chapter with the introduction of charge. Introduction of charge. My dear students, you know the charge is nothing but the excess or deficiency of electron. It is the excess or deficiency of electron. Wherever you need, you can pause the video and note down. Suppose we are having an object. It is neutral object. Neutral object. In chemistry, you have been studied the meaning of neutral object. You can say the total number of positive and negative charges are equal if it is electrically neutral. Now, suppose if a negative charge is removed from this body. Actually, it is neutral body. But if negative charge, here it is electron, negative charge, if removed, then what will happen? This body will have deficiency of electron. Now, this body will be considered as positively charged because positive charge is dominating. So, this is called positively charged body. This is the concept of charge. Another example you can take, if you are having a neutral body again, and you add a negative charge, then what will happen? Now, this body will have excess of negative charge. Now, this body will be considered as negatively charged body, because now this body has excess of electron. So this is the basic meaning of charge. You have studied in very detail the meaning of charge, positive charge, negative charge. I am not going in detail about the types of charges. Now, you have to study the properties of charge. Properties of charge. The first property in standard 10th you have studied, it is the conservation of charge. Conservation of charge, that is, charge on any body conserved. It cannot be create, neither destroy. It can only transfer, that is, it can be transfer from one body to another. Here we have transferred this electron, but this electron is not in air actually. By any means or method, this electron has gone to some another body. Here we are getting electron. Again, we are getting electron to this body by any means or method. Now the second property of charge, student, it has additive property, that is the charge is additive in nature, that is additive property. Charge can be added to any body algebraically because charge is a scalar quantity. You can write as a third property, it is scalar quantity. In this video lecture, if you have any query, you can ask me on my portal. Now the fourth property, which is the very important, quantization. Quantization of charge. Quantization of charge. You must understand the meaning of this quantization. Quantization means whose minimum value is fixed. Quantized means whose minimum value is fixed. For example, you can say our Indian rupees minimum value is fixed, so it is quantized. For example, it is quantized by 1 rupees. You cannot have less than 1 rupees. If you want to get more than 1 rupees, then you can arrange number of coins. Like for 5 rupees, you can arrange 5 coins of 1 rupees. So the quantity, physical quantity that are fixed with its minimum value are considered as quantized. Charge is quantized because charge minimum value is Q minimum, it is 1 electron. You cannot have charge smaller than 1 electron. It is 1 times 1.6 times 10 to the power minus 19 coulomb. If we are writing Q is equals to 1 by 2 electron, then it is wrong because minimum value of charge is 1 electron. So you cannot have this half electron. If you are writing this Q is 3 electron, then it is correct. It means you will get charge in its integral multiple as the positive or negative as integral multiple of charge over the electron as positive and charge over the proton as negative. So n, it is 1, 2, 3 an integer and so on. But remember, n cannot be 0 because you cannot have the 0 charge. Neutral body, you cannot say it has 0 coulomb. It is chargeless, but 0 coulomb will be incorrect. Now the fifth property, students, charge is unaffected by motion. That is, it is free from the frame of reference. It does not depend upon motion of the frame on which it is kept. That is, it is frame independent quantity. For as mass is frame dependent quantity, but charge is frame independent quantity. If any frame is moving with the comparable speed of light, then mass will vary according to Einstein's theory of relativity, but charge will not change. If you put 5 coulomb on a frame and frame moving with the speed of light, then the charge of that value of the charge will not change. Now the sixth property, and this is basically the information, not only the property. If any charge is in static state in a frame, this is the frame, and a charge is in a static state, that is the velocity is 0, acceleration is 0, then this charge will produce electric field only. Remember, it will produce electric field only. That is also considered as static electricity. Static electricity. But if charge is placed in a frame and this charge is moving with constant velocity, remember, if it is moving with constant velocity but acceleration is 0, in this case it will produce electric plus magnetic field, both. Electric field, that is the vector quantity E, plus magnetic field, that is the B, both are perpendicular to each other. In detail, you will study in electromagnetic wave chapter how this can be generalized and considered. Third, if the same charge is moving with variable velocity, that is, it is variable. In this case, what will happen, student? Acceleration will be variable, that is the constant, but not 0. Acceleration will be constant. So in this condition, electric field plus magnetic field will be generated, and you have been studying chemistry by the Rutherford model. It will radiate some energy. Remember, this is the energy. Actually, the same concept it was considered by the Rutherford when a charge moves on circular path. Of course, it accelerates and it radiates energy and finally drop down to the nucleus, which was the drawback. Now the next property, students, that is the attraction and repulsion. The next property, it is the attraction and repulsion. Two like charges repel each other with some electrostatic force. What will happen? Again, they will repel each other with electrostatic force. What will be the amount of force? That is the magnitude of force. It will depend upon the magnitude of charge and separation. We will discuss later on as Coulomb's law. If one is positive and another is negative, that is the dislike charges, they will attract each other with electrostatic force. While they repel each other or attract each other, there will be some gravitational force also But in comparison to this electrostatic force, gravitational force becomes very less. So while solving the numericals, we neglect the gravitational forces, because the gravitational force will be 10 to the power minus 36 times this electrostatic force. So we'll neglect that force. When charge accelerates, that we study, when charge accelerates, it produces, that is a charge moving with variable velocity, that is the acceleration is constant, then it produces electric field as well magnetic field, that, and it must have some energy. So the electric and magnetic field, the very famous question, it has been asked in 1 marks in CBSE. What are the direction of electric and magnetic field? Try to visualize, student. This is the wave of electric field I am drawing over here. It is in XY plane. I am having the Z plane also. It is the XY plane. That is electric field in XY plane and magnetic field in this ZX plane. ZX plane. Magnetic field in XZ plane. So that the magnetic field and electric field, this is the electric field E, and this is the magnetic field B, and this is the direction of propagation of electromagnetic wave, that is electric field, magnetic field. This is the direction of electric field, magnetic field, and this is the direction of electromagnetic wave. So in board exam, it has been asked several times, what will be the angle between electric field and magnetic field? So what should be the answer, student? It is 90 degree. E perpendicular to B, that is the electric field, mutually perpendicular to magnetic field, 90 degree. In next year, the question was asked, what will be the angle between electric field and the direction of propagation of electromagnetic wave? Again, the answer is same, 90 degree. If the question is asked, direction between or angle between magnetic field and direction of propagation of electromagnetic wave, again the answer will be same, it is 90 degree. So you must remember, electric field and magnetic field which associates with the electromagnetic wave are mutually perpendicular to each other. Now students will discuss the next topic. It is charging and discharging of any body. So students, a body can be charged by 3 methods, that is by friction, by induction, and Third, by conduction. It would be better, students, if you study NCERT before listening my lecture, so that you can recall the small question while lecture I asked. It would be better for you. By conduction. Charging by friction you have studied in standard 8th, even in standard 10th. You might have remember the experiment. Small papers were attracted by a comb. When you rub that comb in your hair, the papers attracted towards the comb. In that case, actually comb charged by friction. Charging by friction need actual contact. It need contact. Without contact, you cannot do friction and cannot charge. But this process, charging by induction, actually do not require any physical contact. Body get charged without any real contact. For example, suppose you are having a neutral body. This is the neutral body. I am discussing charging by induction. You are having neutral body. What does it mean by neutral body, student? It means this body have equal number of positive and negative charges. So this is the neutral body. If you will take a rod positively charged and you will keep nearby this neutral body, what will happen? This neutral body, this is the metallic in which charge can easily move within the body. This is the metallic body. Now positively charged rod bring near the neutral body. If remember, this metallic body actually neutralized by any method. As you keep this rod near the body, what will happen? The positive charge will move away and negative charge will attract towards the rod. Now in the next process, remember, you are not making any physical contact with this rod, with this body, spherical body. Now if you keep this body near the sphere, this is the negatively charged and this is the positively charged. This positive charge at high potential you will study later on. Now do earth this body from the positive side. What will happen, student? There will be number of electrons flow from the earth and neutralize this positive charge, because earth is the source of infinite negative charge that can take or give negative charge. Now bring this rod away from this sphere. Since this is being neutralized, now we are having the excess of negative charge. After removing this rod, what will happen? This negative charge uniformly distributed, because the neutral charge has their low efficiency, and this negative charge will distribute over the body, and this body will be considered as negatively charged. So this is the method of charging by induction. In the same way, you can charge a body positively. This is all about today's lecture. In next lecture, we'll study how to charge a body by conduction. Thank you, students.